With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. In the question, it is given that a projectile of mass m, charge z, initial speed v, and impact parameter b is scattered by a heavy nucleus of charge z. Use angular momentum and energy conservation to obtain a formula connecting the minimum distance s of the projectile from the nucleus to these parameters, so that for b equals to 0, s reduces to the closest distance of approach r0. So here we need to prove the for b equals to 0, s reduces to the closest distance of approach r0. So now let's see the answer. So suppose this is our atom, and here at this point this is our nucleus, and this nucleus charge is Zd, and the distance is, let's take this s, and it is followed by the part like this, and whose velocity is given by v, and charge of this particle is z dash e, and there is a perpendicular distance from the nucleus like this, and this is given as v. After reflection, the particle followed like this, and this particle final velocity is v dash, and for minimum distance occur, the angle between the radius and final velocity must be equal to 90 degrees. So now let's take charge of nucleus q nu equals to Zd, and charge of the particle q particle is equal to z dash e. So initially our particle is far away, so here we take the distance is infinity. So at infinity, angular momentum about nucleus is given by Li equals to mvb, and at the closest distance s, so at s, angular momentum about nucleus is given by angular momentum final equals to mv dash s. Now from the law of conservation of momentum, we can say that initial momentum Ni equals to final momentum, and now we can put the values of initial momentum and final momentum. So initial momentum is mvb equals to final momentum is mv dash s. From here we got the value of v dash equals to vb by s. Let's take this equation number 1. Now initially the kinetic energy is, means at infinity, kinetic energy initial equals to half mv square, and potential energy at initial point is equal to 0. Now come to the at distance s. So at distance s, kinetic energy final equals to half mv dash square, and potential energy final is equal to 1 by 4 pi epsilon naught q1 q2 divided by d. So from here we know the charge q1 is Zd and q2 is Zd, and distance is s. So from here final potential energy is 1 by 4 pi epsilon naught into Zd into Z divided by s. Now from the law of conservation of energy, we know that initial kinetic energy plus initial potential energy equals to final kinetic energy plus final potential energy. So from here we got that half mv square plus 0 equals to half m v dash square plus 1 by 4 pi epsilon naught into ze into z dash e divided by s. Now from equation 1 we know the value of v dash. So here we put the value of v dash, then we get half mv squared equals to half v squared by s squared into m plus 1 by 4 pi epsilon naught into ze into z dash e divided by s. Now s square taking on this side, then we will get half m v square s square is equal to half m v square into b square plus 1 by 4 pi epsilon naught into ze into z dash e into s. Now dividing both sides by half mb square, then we will get s square equals to b square plus 1 by 2 pi epsilon naught into z dash e square s divided by mv square. In the question, it is given that for head-on collision, the value of b equals to 0. Therefore, from the above equation, we put the value b equals to 0, then we will get s square equals to 1 by 2 pi epsilon naught into z dash e square s by mv square. Here s and s is cancelled, therefore we will get the value of s equals to 1 by 2 pi epsilon naught into z dash into e square divided by mv square. Therefore now we get s is equal to 1 by 4 pi epsilon naught into z dash e square divided by half mv square, and this is the r naught. This is the distance of closest approach, hence proof, and this is our answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.